How is everybody doing today? Good? It's hopefully going to get warmer again soon.
Tomorrow. Oh wait, yeah, I think it's supposed to be tomorrow, like kind of.
I mean, one of these days we'll have actual spring, and then we'll be dying of all the pollen, and that'll be
I will for sure.
a glorious day, I'm sure. Where we all just are like, oh, it's so warm, but my nose so stuffed. So today we are going to talk about more of the Monte Carlo kind of stuff. But before I do that, I want to talk a bit about the final project as we are getting closer to it. This is not to panic you or to say, oh, you got to start like worrying about this. This is more where you start kind of just getting. I want to just start giving you an idea of the kind of range of possibilities you can think of, because I want you to know a few things about it. First off, because it's been a while since I talked about it. First off, you can pretty much do it on whatever you want, and you can do it in whatever language you want. So you do not have to do it in Python, right? In fact, if you're making an app for Mac OS X or for Mac iOS, you definitely can't use Python for that. If you're making an Android app, similar, right? But if you're making a Discord bot, you can totally use Python for that. You can also use a bunch of their models. If you wanted to make a bot for the site that was formerly known as Twitter, then you can make then there's a number of APIs for that. But Discord bots are pretty common. One of the most common things that I get is games, and those can be, that is a wide variety of topics. So games can be done in, like a recreation or a remix of an old game like Snake or Tetris or something like that. Those kind of games, I always get that. I also get a lot of people making their own custom games. So like 2D side scrollers and that kind of stuff. If you're interested in doing so for making a game, there's a couple different options. If you're working just natively in Python, you have access to Pygame, which is this wonderful library that is useful for making games in Python. There are, and you can just do it all in Python. There is a textbook that goes alongside it. Okay. There's a textbook that is free that you can find with, I think it is Making Games in Pygame and Python. Yeah, invent with Python. So here. And this goes through how to do this, how to install Python and Pygame, and it goes over how do you make a bunch of cloned games, like a cloned game for a Snake, which it calls Wormy, Squirrel Eat Squirrel, which is this one. It's Katamari Damacy kind of thing. Tetrimo. So basically how to make these kind of games in Pygame. If, however, you actually want to but say you are actually interested in doing this maybe professionally, okay? Because I know a lot of you, that's a common reason why people will join up. Like they have an interest in actually making a game. Then in that case, you probably want to try your hand at learning a actual professional game engine. And this is basically your opportunity to do that thing you've been planning on doing for a while, but doing it for credit. Basically, if you show me a concept, a working proof of concept of a game or a vertical slice of some kind. Hey, I've got a small level where I can drive around and blow things up, or I've got a level where I'm running and trying not to fall off these platforms, right? Then that's an A, right? These are, especially if you do it in one of these platforms. There's a lot of platforms for doing these in. There's the Unreal Engine, right? Which is, that's Epic's baby. So think Fortnite, okay? They make a lot of stuff. It is one of the primary game engines. Another of the big primary games engines is the, not Unreal, I just did that, it's Unity. And they, by the way, most of these are free for like students at the level you're going to be doing it. It's only like when you start making actual grown-up money that they expect you to start shelling out for these. So, but like a lot of games are made with these because making physics engines are hard. And if you want to make a kind of a game, I guarantee you there are YouTube tutorials on how to make that genre of game that you can follow and learn and then get an A on this project on, right? You don't want to make a one-for-one clone of that tutorial, but the idea here is that you can use that as a basis and then create your own assets or whatnot, or find your own open assets and just basically make it your own in some way, okay? If, however, subscribing to that corporate model does not really appeal to you and you want to use something open source and free and actually have freedom and not be like beholden to the whims of a large company, the Godot engine is really good. Like, really, really good. Godot is free open source 2D, 3D engine for making tons of games. Okay? It is wonderfully good. One of our TAs, Mariam, I believe, she speaks very highly of Godot, if I remember correctly. Then, if you're also interested in, but you don't even have to do that. There's other tutorials for other engines. For instance, Lua with Love. If you were playing Balatro, then you played a game that was made using this engine called Love, which allowed you to make 2D games in Lua, which is another programming language. Yeah, you'd have to learn another programming language. You want to know something scary? It's not actually that hard now that you've learned one. It's really not. Okay? Because basically it's just learning how to do the same structures you already know, just in a different language. How do you make variables? How do you do an if statement? How do you do a for loop? You don't need to work out what a for loop is anymore, what a while loop is, what an if statement is, what a function is. You already did that hard part. Now you're just translating that knowledge. Okay? If you are interested in doing something in a much more kind of retro style, oh my God, the Pico 8 is for you. Pico 8 is great. Basically, it's an entire built-in editor and programmer. It's got restrictions on it, like creative restrictions, like only so much space, only so many colors. But you do all your programming in it, and you can make all these beautiful retro games, and it feels great to play in and to make them. And they play in, and the games are just, they're stored in these tiny pictures. That's what these are the games. You store them, and then it's loaded up into the virtual emulator, and then you play them. It's so cool. Oh, it's a Baba Is You demake. That's wonderful. Oh, Baba Is You is great. Baba Is You is one of my favorites. Get to the flag. Yeah, you better. Wall is stop. Right? You can't go past the wall, but it writes down the rule, and you can break those rules apart. And then you just simply, and then how do you win? You say flag. It's one of these old kind of pushing games. So Baba Is You should check that out if you haven't. It's kind of great. By the way, you don't need any artistic skills to make games. You can Thomas Was Alone. The game characters are squares. Congrats. It's still an amazing game. West of Loathing, I believe. Great game. Stick figure art. Right? The art should not get in the way. Finally, a good default project I set up for students, if you really do want to work in Python and have no idea what you want to do, is try making yourself a visual novel. Okay? Games, so there's an engine called Ren'Py, and it's used to make games like one of my personal favorites, Slay the Princess. Okay? This is a great game for the and it's just beautifully illustrated, and it's a choose your own adventure game. so it's got a lot of text. It's like reading a book, but it is a game. Also, one of the games, but this was made in Ren'Py. Another game that I love in this genre that I really enjoyed, that's free. It's Doki Doki Literature Club, right? And I see nods from the students who know. If you know, you know. And if you don't know, go in blind unless you're easily disturbed. And that's all I can tell you, because this is not one, because it looks like one of those games. I promise you, it's not one of those games. It's one of those games. The ones that really mess with you. It's fantastic. It's great. It takes about 2 to 3 hours to play. It's wonderful. It is fantastic. Right, but that was also done in Ren'Py. Ren'Py, just this wonderful visual novel engine that's used to make that you can make these wonderful visual novels. Oh, You Are the Hero. This one was a very fun one as well. It was very fun. It was basically Bad End Theater or something like that. It was great. It was basically trying to figure out how you can get a good ending to this game with the hero and all the rest by changing how they would approach things in certain situations. It was pretty fun to be Bad End Theater. Bad End Theater, that was it. Right? Used Ren'Py. It's a really good engine, and it's all in Python, and doing that would let you kind of... I've seen a lot of very self-expressive projects with this. So gaming has a lot of, there's a lot of things you can do, and if you really are completely lost on gaming, I've got 2 tutorials here for that you can follow along for building a game in Lua with Love that is posted by the Harvard CS50X website. These are probably outdated. These because mobile apps and their operating systems get updated. So these are probably well out of date right now. The ones for these are like default projects that with tutorials I provide. And then you could always build a web page, be it a static web page for your, I've seen students build web pages for their businesses or their friends' businesses, or you can build like something like a fake stock trader, right? Which I call stonks. But it's the videos on how to, but the videos are there on how to basically make a fake stock trader to see how much money you would actually lose day trading, So it's a lot of, so there's a lot of possibilities you can do. You can build stuff with actual gadgets. That's another thing, right? If you wanted to build like a laser detector, a laser alarm kind of thing that with a Raspberry Pi. I'll be showing that off, a video of that off at some point. So if you want to include something that you're busy working on for your own final project in another class, that's something you can talk about. I've had students who were in music and they built plugins for their DAWs, digital audio workstation. So building a guitar distortion filter. There's also some students who worked in the Juice framework. Juice. It's Juice, Juce, which is for building VSTs, plug-in virtual instruments that are used in digital audio workstations. So if you want to learn how that works, that's a way to do it. I've also had students work in, this was hilarious. I've had students work in Max MSP, which is another system, right? This is an old interface of Max MSP for doing this. And I remember I had this was back when I had the TAs do a lot of the grading for this. He gave this a 0. And he's like, I have no idea what this is. And I'm like, oh, I know exactly what this is. This is amazing. That's what this is. Because Max MSP doesn't look like any kind of programming thing you would normally be doing because it has all this drag and dropping. But if you notice, there's if statements here, right? There's if statements with commands and stuff. It's an actual instrument. If you wanted to, let's see, command line music. Not play, but not these, but basically, let's see. Writing music via code. What is it? Strudel. That's it. All right. If you want to make music doing this kind of thing. Let's see. Can't identify what CC is. I'd have to look it up. Change play, but I've never actually really used this, but it's a way to do let's see, to do basically it's just a your interactive tutorial. Here's an example of how it can sound. And because this is code that is running, you can modify this in real time. There's a number of YouTubers. There's a few YouTubers who have done stuff like this. And if you wanted to try, and I'd be amenable to a student if they wanted to try doing this. What was it? There was bass. Not bass. Bass. Yeah. And for, I'd have to look it up where it was, but it was I've seen a number of good pieces that came out of this, typically in the electronic music scene, using this. It is certainly a different way of writing these kind of writing music. Certainly a very different way of writing music. But like, there's a full tutorial, and if you probably stuck around with it for like 4 hours, you could probably do something pretty impressive with it. So if you're interested in music, try it out. What's the worst that happens? You wasted a few hours. Oh no, there's worse things in the world. So yeah, as you can tell, I'm fairly passionate about like doing about just trying things out and seeing if it works for you, and that's what I hope to see. Like I'm very open to what these kind of ideas will be. What am I going to say no to? I'm going to say no to things like tic-tac-toe and hangman, right? Those are things that are typically regular, plain old homework assignments. If you come to me and say, I want to do hangman, I might direct you to a project we do in 2 classes from now, the Cheaters Hangman. Oh, hey, video from me, great. I think it's actually called Evil Hangman in the original write-up, which basically says it's a very simple program, but basically it means that you make a game of Hangman that's very difficult to win. It works the same way as Absurdle, which if you've ever played, I'm sure a lot of you have played Wordle or seen it, right? This is by QNTM, who's a wonderful author. Very interesting programmer from what I understand. But anyway, this game, wonderful. And by the way, I've had students do Wordle, like make a Wordle web page, and that's been a great final project I've seen. So, where they implement it by themselves. Right, so let's go ahead and just do sound as our first word. And we get everything wrong. What about price? Okay, we see we have an RE. What about, let's go. Even though I know there's no D there and an S, I'm still going to do it. And I'm going to go ahead and click give up. It's going to tell me it was the word I was looking for was alert. Actually, don't give up. I'm going to go and put in alert. It tells me I was wrong, even though it told me actually the word it was thinking of was alert. I'm going to give up again. Harem. Actually, don't give up. No, I was wrong again. What it's doing here is that it's not playing fair. You see, Wordle is simply basically saying, hey, the way Wordle works is that it basically assumes you're choosing a word and you're trying to find it. This is breaking that assumption. Notice that we're going well over the number of guesses we have, right? The entire point of this is that it chooses all possible words, and then it basically says, okay, based on the guess you make, let me categorize them on possible feedback I can give you, right? Whether they're all wrong, some of them are right, some of them are in the wrong position, but the right letters, right? I'm going to basically split all the words into different categories based off of which of those answers you could, based off of what you gave me and what you've given me in the past. And then I'm going to choose whatever category of those that gives me the most answers to play to mess around with, so that I don't accidentally give you a word that was illegal based off of your past guesses. So it basically narrows this down. The evil hangman works in exactly the same way. If you wanted to make your own own variation of Wordle, like Hyper Wordle, I think it's this is a fun one if you've not played it. Is it? No, it was not Hyper. Oh yeah, Quordle. There we go. Where you try to play 4 games of Wordle at once. So, if you want to make some variation off of a game, right, even better than just making a game because you're making it your own in some way, okay? So, if you haven't figured it out, I really like games. I really like music. I really like and I like seeing games from this group of students specifically. But it doesn't have to be games, okay? And I will be sharing with you a list of some of the best projects I've seen in the upcoming weeks. But I wanted to kind of show you that. Now, with regards to the next exam, because I have gotten some emails about that, I'm just going to go ahead and send out the practice exam, briefly kind of show you what's going to be on it so you have an idea of how much more there is to learn, not that much. And then we'll go on and work on the more Monte Carlo stuff, okay? This is the part of the semester where I do ramble on a bit about various things. So, practice exam 2. Publish. Actually, practice exam 2. Publish. There we go. I'll remind you about the dates and the restrictions for the next one. But it's not next week. So there you go. That's the important thing. But for this one, what kind of questions will you be getting? Not these questions. I got to remove those. But this is an actual question from one of my exams, from one of my previous exams. I moved to a practice exam, which here is a file called temperature CSVs, which has the highs for the days and the lows for the days, right? The date, the high for that day, and the low for the day. The example file might look like this, and I want you to find the highest high temperature and the lowest low temperature and the average high temperature. So if you've done the Hurricane Lab, this is actually fairly straightforward, right? This is just a file reading program and basically looking for the max. And I typically give you an absurd amount of space to work on a lot of these problems, so it does make it bigger. There's a number of string manipulation questions, such as, hey, we've got a word. If it starts with un, I want to remove the un. If it has un, I want to add un to the front instead. Given a list, give me the first half of the list. Give me the sum of all the numbers in this string. So 1, 2, and 3. Since 1, 2, and 3 are in this string, will give me back 6. And then typically one Monte Carlo problem. Here's a game. Here we have Monopoly, which is a lot harder than what I normally give on the exam. But it's not the entire game of Monopoly I'm asking you to simulate. There's a special rule. Everybody thinks they know the rules to Monopoly. They don't, because nobody bothers reading the rules. Right? You've all learned it from somebody else who play, right? So anyway, the way, so this one specifically asks you for Monopoly, can we calculate the odds of getting what's called speeding, where you roll, what happens in Monopoly if you roll doubles, which is like you roll the same symbol on 2 dice. So you roll 2 twos, 3 threes, 2 twos, 2 threes, 2 fours, 2 fives, or 2 sixes. You essentially get an extra turn. But if you do that 3 times in a row, then you go directly to jail. So what are the odds that happens? Which is about 1%. And write a program that would calculate the odds of that happening rather than trying to calculate it yourself, right? And if you do it correctly, you'll write a program that will essentially be able to calculate, oh, it happens about 1% of the time. And then with the dictionary question, you'll get something that looks very much like this. Given a string, write a function that returns the most common letter in the string. We did that in class. Okay, so a good thing we have a list of notes. Here's another Monte Carlo problem. I only do 1 on the exam, but I give extra. But notice I label it as extra practice. And this is another scam game, which I'll be happy to go over, which is basically, hey, actually I won't explain it because I don't want to take too much time, but basically it's you try to figure out which of these sequences will come first. So yeah. So with that, let's go ahead and head to Runestone and talk about our problem. As far as the exam itself, we check the calendar. Right, it's not next week. I typically give it on week 11, which would be this week. So most likely your exam will be on Friday the 3rd or April the 6th, depending on when you actually have your lab. Okay. As far as the third midterm, that exam, that's going to be on the very, very, very last lab you have. Okay. Now remember, it is the best 2 out of 3 for these midterms, right? You've got 3 midterms and a final, but for those midterms, it's best 2 out of 3. So in theory, if you're happy with your grades on the first 2 midterms, you can just totally skip the third one, right? You take a 0 for it, but that 0 gets dropped. So on the flip side, if you did terribly on the first exam, you probably want to do well on these next 2. Okay. So what we're going to do is we're going to go to Runestone. If we go to modules, we scroll down to our dictionaries. Not dictionaries. Module 9, which is Monte Carlo, approximations in cheating and statistics. We're going to talk about one of the most famous statistical things in mathematics, which is the Monty Hall problem. If you haven't watched this video yet, then this is going to come as a complete shock to you. And if you have watched this video, great. This is just going to be a reiteration of the same thing you've seen. And we're going to prove it by using coding. So Monte Carlo simulations. This is going to be done in the last slot over here. So this is the third problem. Unfortunately, the old video is gone, but there used to be a game show called Let's Make a Deal, hosted by this man, Monty Hall. This is why it's named after, is why it's called the Monty Hall problem. And notice that under the stats over here, we have pictures, Canadian television host, and then we have Monty Hall problem by Oxford Mathematics, right? In the Monty Hall problem, basically the idea of let's make a deal, it's been presented a few times, but most famously it was presented in Vos Savant's column, where it was a brain deal based on Let's Make a Deal show. And the idea here, it was originally posted in American Statistician, but it got really famous when it was in Ask Marilyn's column in Parade magazine, where you could just ask Marilyn thing. She had apparently the highest IQ in the Guinness Book of World Records, which is a category that has been retired. Regardless of what you feel about the validity of IQ, getting a really high score probably means you are pretty good at math or something like that. So anyway, the original way it was phrased, and we're going to use the original phrasing because we need to be clear here. Suppose you're on a game show and you're given the choice of 3 doors, door 1, door 2, or door 3. You pick a door, say door number 1. And the host, who knows what is behind each of these 3 doors, opens one of the other 2 doors. In this case, we're going to open door number 3, and he reveals there's a goat. Now, behind 2 of these doors is a goat, and behind one of them is a car, right? And this is the part that doesn't get stated, but I should state it. For the purposes of this argument, you want the car. Okay, I have to specify this because my wife is one of those who would choose the goat. Right? X case. And yes, there is a relevant XAC, Monty. Right? My yard has so much grass, and I'll teach you tricks. And right? So, anyway. So we've got these 3 doors. Behind one of these doors is a car. Behind 2 of them is a goat. We've chosen door number 1. Monty opens door number 3 and reveals there's a goat behind door number 3. And then he asks us the question, do you want to switch or do you want to stay? Is it to your advantage to switch? Your choice. And that question it would have broken the internet had the internet been a thing, but it was not. So it just simply broke the column. Because what Marilyn answered is, yes, it's to your advantage to switch. It is your advantage to switch. Now, many of you are thinking, it's to your advantage to switch maybe because now the odds are 50-50, right? Because there's only 2, you either switch or you don't switch. So your odds were 1 in 3 earlier, now they're 50-50. But Vos Savant said, yes, it's in your odds to switch because your odds of winning if you switch are 66% versus 33%. The switching strategy has a 2/3 probability of winning the car, and the strategy of keeping your initial choice is only 1/3 probability. And this makes total sense to me because I have seen this problem so many times. I do remember when I was originally introduced to this problem, I was flummoxed, absolutely flummoxed. And maybe you are, maybe you aren't. Why does this make sense? We've went from having 1 in 3 to 1 in 2, or now we're switching, but why does it become 2/3? The idea here is that when the player makes their first choice, there's a 2/3 chance that the car is behind one of the doors that you have not chosen, right? If I choose 1, I only have a 1 in 3 chance of getting that car initially, okay? And now that the host has revealed additional information, revealing one of them doesn't have a car, the 2/3 of chance of being behind one of the unchosen doors kind of combines together. In a response, Savant states, suppose there's 1 million doors and you pick door number 1. The host, who knows behind what's all the doors and will always avoid them with the price, opens them all except door 777777. You'd switch that door pretty fast, wouldn't you? That is the example I like to kind of give. If instead of 1 in 3, we have 1 in 1 million, right? Your chances of getting it right, are you sure you got it right with that 1 in 1 million chance? And the answer is yes. 1 in 1 million chances happen 9 times out of 10, and we see that in every story. Can't make that shot. It's 1 in 1 million. Anyway, this was I did set to create a bit of firestorm. The problem appeared in Parade, approximately 10,000 readers, including 1,000 with PhDs, and I would assume even math PhDs are among these, wrote to the magazine and called Savant wrong. Even when given simulations, explanations, and formal mathematical proofs, many people did not expect this. And I bring this up because Paul Erdos, extremely famous mathematician, one of the most prolific mathematicians of all times, to the point that if you know that, so actors have a Bacon score, which is the degrees of distance from which you have to Kevin Bacon. 0 for being Kevin Bacon. 1 if you've acted with Kevin Bacon. 2 if you've acted with somebody who's acted with Kevin Bacon, right? And that goes up. Mathematicians have the Erdos score, which is 0 if you're Paul Erdos, 1 if you've published with Paul Erdos, 2 if you've published with somebody with an Erdos score of 1. An Erdos score of n is if you've published with somebody with an Erdos score of n-1. My Erdos score is 5, so I published with somebody who had an Erdos score of 4. So anyway, he was very famously, mathematician, and he was unconvinced until he did what we're going to do today, which is to simulate this to show that she is right. Okay? It is a paradox, right? There are a few different paradoxes that are relevant. If you plan on if you plan on going into law, there is one statistical paradox you must know, which is the Simpsons paradox, which is not named after the Simpsons cartoon. But it's actually more related to baseball and things like that. But it's relevant because it often comes up with, like, in cases of bias or statistical bias, which basically shows, hey, just because bias in one department or what looks like bias overall may not be bias in individual departments. Kidney stone success rates may not be, the treatment may not. Basically, based on what the numbers are, you may get confounding results. The typical one we see here is comparing Derek Jeter to David Justice and their batting averages. And we can see here that despite Derek Jeter having a lower batting average in the 1995 and the 1996 season, right? He had a batting average of .25 and .314, which are extremely respectable. David Justice had higher batting average in 95 and 96, right? We can see that. But when you combine those 2 years, Derek Jeter had a significantly higher overall batting average. And that's just because of the way the numbers shook out, right? Being at bat way more times or having more attempts to hit. And also just, you can see that this year he had a lower batting average, but it did not play as much of a role as this year, right? So the numbers, when they combined and aggregated, revealed a completely different result. And this occasionally happens. This is actually like the classic example of Simpson's paradox. The one about gender bias is more relevant if you're in the legal profession, if you're going to the legal profession. But it's good to know that this just can happen. And statistics can be weird like that. So if things about statistics seem weird to you and not making sense, that's okay. You're not alone. Okay. So how do we simulate this so to make sure that we don't, because it says the math is pretty complicated for figuring out the Monty Hall problem. Right? We can, but honestly, it's not too bad. But like when you're doing proper Bayes theorem analysis, that's when you can, that's when the math starts to look a bit complicated because we start using functions and things like that. But again, simulation shows basically the best way this works. So what we're going to do over here is we can simulate this. So we do this, and you're going to see this works exactly the same as the way I did it yesterday for our card problem. We're going to import random first off. And then the next step is I'm going to do two things. I'm going to do a setup function, and I'm going to create a def game function. Okay, the game function, the way it's going to work is that I'm going to just go ahead and return false right now, okay? But I'm going to do the end of this first to kind of just show you, right? The last time we wrote this, it had a setup function and a game function, we're going to do 100,000 trials of this game, right? Trials equals 100,000. That seemed familiar, hopefully. For blank in range trials. If game equals true, wins plus equals 1. Let's go ahead and define wins. We're going to count the wins, set that equal to 0. So we run this 100 times. If the game is true, print wins divided by trials. Now, obviously, right now we're not actually playing, so of course, if I run this, I'm just making a for loop that says, hey, you're not playing, so I guess you lost, because all our game does is return false, saying we lost right now. But notice that this is that basically it's the same code as what I wrote last time, right? Trials, wins, how many times, and we just count out every time we win the game. So right now, let's go ahead and set up our let's write our setup function, which builds the game so we can play it, right? The game is very simple. We have our doors is equal to, and I don't have to do anything crazy here because we've only got 3 of them, but we can say goat, there's 2 goats. I'll do it this way just in case we want to change the numbers later. And 1 car, right? So I could just simply do it like this. Goat, goat, car. That other way would have been more modular. But anyway, we've got doors. And then what we'll do is we'll set it up so that we can do random.shuffle. So that we shuffle these doors so that they will appear in a random order, right? Right? If I go to idle for a second, right? If I import random, right? If I do this, if I do these 2 commands, it doesn't want me to do multiple statements here. So if I do these 2 commands where I set up doors, why am I copying that one? I don't want to copy that line. Jeez. Okay, there's my doors. If I do random.shuffle, right, we'll see that doors didn't really change because that is a random outcome for shuffling these 3 things. Really? Give me 1 sec. Oh, okay. Give me a second. I was like, where is that? It's on the other screen. Random.shuffle doors, doors, and there. So it was just bad luck that I had gotten it twice in a row, right? There's a 1 in 3 chance of this outcome, essentially, because it's basically asking where's the car going to go. Okay, so this works at shuffling it. And then we're just going to return our doors. Game is equal to, and I keep it as a separate function just in case it gets more complex, right? So doors is equal to set up our game. And then what we're going to do is we'll go ahead and play with the strategy of this game. I'm going to just simply choose door number 1 every single time, okay? So what I'll do is I will choose door number 1 every single time. And so if door 0 equals goat, then that means that essentially that he's going to reveal another goat, right? If I opened up door number 1, he's going to reveal door number 2 or door number 3 to be a goat. And then I'm going to switch that. And because I was originally on a goat, he revealed a goat. The only thing I can switch to is the car, so I'll win. Make sense? Otherwise, if I'm on the car, else I'm going to be on the car. Right? And if I'm on the car, that means I'm going to switch to a goat, doesn't it? Right? In which case, I'll return false. So now we run this. Name error, door is not defined. Oh, I wrote door 0 as opposed to it's a collection, and I pluralized it. I make this mistake a lot. Doors, that was my error. I had door here, and I should have had doors because this is doors. Make sense? Hope it did. And says I have a 66% chance of winning. But Professor Rosen, you're always choosing the first one. What if you just choose at random? Okay, let's choose at random. If random dot choice doors, I'm going to choose one at random. If I happen to pick a goat, he's going to reveal the other goat, and then I'm going to switch. Same deal. 66% chance of winning. Code for this game can be extremely short. You can be you can do something much more detailed. I'm going to go ahead and share this code just in case you missed something, right? Because I want to make sure you have access to it. So again, the way you see that is that you'll just want to, this will appear in your timeline at this timestamp for you to do. So it's a lot of fun. You can play around with this with actual physical cards if you want to kind of see this work in real life. Now we're going to just combine now we're going to do one of our mega problems. It's just a mega problem because it combines a lot of concepts we already know, because it's going to combine the concepts of turtles and randomness, and something we did a while ago. This will unfortunately require a bit of geometry. I promise you it is not hard geometry, but it is weird, okay? So we're going to approximate pi in a very kind of fun way. So if you remember, we approximated pi earlier in the semester during lecture 5 using this formula, right? Pi over 4 is equal to 1 over 1 minus the third plus the fifth minus the seventh plus a 9. You remember that, right? That was a fun time, right? The Monte Carlo is a bit more fun and intuitive to understand. Now remember, when we're calculating pi, we are calculating the difference we're calculating the ratio of the circumference to the diameter, okay? Instead, what we're going to do is something completely different. We're going to calculate pi by throwing darts at a dartboard, okay? Suppose we're throwing darts at a dartboard. Many of these are going to hit the board and some are going to miss. Specifically, we're going to create a bit of a limited space, okay? Okay, we're going to have a wall, okay? We're going to have a wall and a pretty big door, okay? So I'm going to go ahead and I will have undo. I want a circle. Be a circle. There we go. We have this dartboard. And we're going to set its size to be 1. It's going to be a unit circle. Okay? Make sense? So that means its radius is 1. Okay? And it's a pretty big board. It's going to be on this wall. Okay? this dartboard will be on this wall, right? And now I just got to shrink this up. There we go. All right, assume that's a square and a circle in it, okay? So we've got a dartboard on a wall, okay? This is the entirety of the wall. So if we throw a dart, it can't hit anywhere. If we throw a dart at the wall, it can't hit anywhere but this circle or this wall. Make sense? Now, I mentioned that this is a unit circle. Okay? It's a unit circle. That means that the radius is 1. Now, if this is a square and we see how everything is touching, this is and this center of the circle is also the center of the square, okay? Then the side length of this square is 2. So let's do, again, I mentioned this is geometry, but it is super basic geometry. If the side of the square is 2, right? If the side of the square is 2, then the area of the square is 4, right? Side 2 is 2. So the area has to be s squared, which is 4, right? The area of the square is, of the square is 4. Similarly, we know that the radius of this circle is 1, and we know the formula for the area of a circle is pi r squared. Very basic math here, right? Very, very basic math here, which is 1 squared is equal to 1. So we know that the area of the circle is pi. We set this up intentionally so that we would get pi as our area, okay? So the ratio, so basically we've got a 4 to pi ratio here, right? A 4 to pi ratio here if we have a, of the square to the circle. The square is bigger than the circle, right? 4 is bigger than 3.1415, right? So, now here's the kind of the bit that we're going to do. Again, this is a wall. If I throw a dart at this entire setup, it's either going to hit inside the dartboard or outside the dartboard on the square, right? So it's going to hit inside the square no matter what. It's just a matter of where it's going to be on the dartboard, okay? So if I count the number of hits in the dartboard and I divide by the total number of throws, right? If I do the total number of hits, divide by the number of throws, then that should be equal to basically the area of the circle over the area of the square, right? That should be equal to pi over 4. Make sense? So if I throw enough of these darts, I'm going to get pi over 4. So this will enable, so I can calculate pi by throwing darts, essentially. So how am I going to do this? By throwing darts. And the answer is we're going to ask our old friend Bob to be a good sport here while we throw him against the wall again and again and again. Okay. So first off, we need to make a dart. We need to make our board, so to speak. Okay, so we're going to need two things. We're going to need random, and we're going to need to have our turtle, right? And we need to basically have a way to get Bob to go on this board. So Bob is equal to turtle.turtle. And let's see, does this create a square or no? We'll say Bob.shape. I'm just going to set him up to be a turtle. And hopefully that will make him pop up on the screen. Right. So the first thing we really need to do is make this square the wall, right? And if this square is the wall, like if we consider this point to be 0, 0, right? If we consider this to be 0, 0, and this has a radius of 1, right? And this is a radius of 1, and this is a radius of 1 to over here, right? Then this point over here would be x is 1, y is 0. This would be 1, 1, and this would be 1, right? If this were laying on a coordinate plane, right? -1, -1. Okay, so what we can do is that we can take a page out of our program from Hurricane. Turtle set world coordinates. I remember that just simply because of all the times we've had to use it. I've had to use it, not we. This is like the second time you're seeing it. Set world coordinates. And are you going to have to know this command for exam or even the final exam? Hell no. Okay, it's just worth knowing. Or sorry, it's just, I just know it because I know it, and I have to look it up every time how to use it. It's for coordinates that are LLX, LLY, UR right, URX, which, or Lux, Lui, Urx, and Uri, which if you read those, you'd probably, without any context below, you'd have no idea what those mean. But once you've seen it once, you kind of know what it means. And let me explain them. LLX is lower left X, lower left Y, upper right X, upper right Y. Assuming you're setting a square up, then you basically just need two corners to define the square. The bottom left and the upper right corners. And if it's a square, then that's all you need to define the square. Or any rectangle, in fact. Right? So, what we're going to do is we are going to all right, it's in here. So we are going to go ahead and, you know what, I think I'll work in Genie, and I'm going to go ahead and I'm going to work in Genie, and then I will copy it over, okay, because that way the UI doesn't get into this. So dartboard.py. I just like working in here, okay? So I'll need to do turtle.set. What is it? Is it, I have to remember if it's, nope, it's all lowercase, one word. Set world coordinates. Hopefully I spelled that correctly. And then it's going to be -1, -1, 1, 1, as we discussed for those two corners. Let's run it, see if it ran. It disappears immediately because I'm not using idle, so I got to do turtle.done over here, which is what you need to do if you're working in VS Code. There we go. And now we need to test this. I'm going to tell Bob to go to 1, 1. Oh, that's that issue. I just hit this. Bob, go to 1, 1. And you notice he goes to the corner of this, right? If I did not have set world coordinates set up, then it would just simply use 1 pixel is equal to 1 step, and so we barely even see him move at all. So that's what this does. It sets this entire square up so that it represents what we want to do. So now, how do we get Bob to go where to do what we want to do? So what we're going to do is we're going to throw him at the wall a bunch of times, as we said, okay? So we're going to go ahead and define a throw function, def throw, which is going to take in Bob. It's just going to take in the turtle we want to throw. In case we wanted to throw multiple turtles, we could switch up who that is, okay? And what we have to do to throw him is assume that we're not very skilled at throwing, so we could go anywhere we wanted. We're going to go ahead and throw him, say, at any point on that wall. So we need a random x and a random y. X is equal to, and then we need a random function. Randint would give us an integer. We need a decimal, right? So let's go ahead and look up random. I believe it is random.uniform. Again, these are things I have to look up, so don't feel bad of like not knowing this because I had to look this up. but I believe uniform talks about uniform selection, meaning any of them are equally possible. Random.uniform returns a random floating point n such that n is in between inclusive a and b. Random floating point. Okay? And it says it may exclude b if, rounding issues cause problems. So random.uniform. This is going to give me an x. Okay? And random.uniform, not x, random.uniform 1, -1, 1, because the possible, why -1 and 1? Because our possible ranges for both x and y are -1 and 1, right? Does that make sense? So it's any number between the negative x, between 1 and 1 for x, any number between -1 and 1 for y, and then we'll just simply tell Bob to go to that position. X, comma, y. Okay? And so for blank in range, well, we're going to be doing this like a Monte Carlo thing, so trials is equal to 10. So for blank in range trials, because we can change that later, Bob, so we're going to throw Bob. And hopefully he'll forgive me. So, I forgot a colon. Run. What did I forget? What did I miss? What did I not do? Oh, right. I forgot to uncomment this out. That's what I forgot to do. So he is moving, and he did move. We just totally didn't see him move because he's sneaky right now. Now we uncheck this from negative, so now we're working back on our dartboard. So now if we run this again, we see that he's hit a bunch of random things and he's just going to bounce over. Let's have him actually mark where he's going, where he's been. That's fairly straightforward to do. What we're going to do is we're going to tell him while we're setting him up, Bob dot pen up. We don't want him scribbling all over the screen. That's not how darts get thrown. We're going to say, Bob, we need you to go fast to make it look like you're being thrown and stuff. And when you go to that location, what you're going to do is you're going to go stamp at that location. Okay? So pen up, speed to 0. 0 is not slow. 10 is fast. 0 is as fast as possible. Ignore seeing how fast you can go. And there we go. You see that went pretty quickly. So I'm going to go ahead and do maybe 100 of these. And we see Bob basically appear, get thrown repeatedly against this wall, and I'm sure the Society for Prevention for Cruelty to Animals is on its way right now, but Bob's a good sport. So let's actually make this make sense though, because we need to see whether or not we hit the board or not, and we're going to do so visually. Okay. So how do we tell whether we hit the board or not? It's actually fairly straightforward. The radius of the circle is 1. If we land inside the circle, then our distance from the center will be 1 or less. So we just calculate, is our distance from 0 1 or less? And that's actually fairly straightforward to do. We are unfortunately going to need one more library. We're going to have to use math. I promise you, now this is a formula you can look up yourself. You may have been taught it and totally forgotten about it, but this is the Euclidean distance formula. I just simply know it because I've had to do this a lot of times in a lot of classes, but basically the distance for any vector of anything from the center is as follows. the distance is equal to, we square the x-coordinate, we add that to the square of the y-coordinate, so we square our coordinates, okay? And then if you had a z-coordinate as well, because it was 3D and other, as many coordinates as you'd have, you'd add them up and square them. And then you take that and you throw that into the square root. So it's the square root of your x-coordinate and your y-coordinate squared each. So, and that will tell us, and if that is 1, that or less, then that's in the center. So what we'll do is we will say, hey, if dist is greater than or, sorry, is less than or equal to 1, because again, we're looking to see if it hit, then what we'll do is we will say bob.color, and this should work, just simply saying, hey, I want his color to be blue like that. And if it is not that, then I'm just going to say bob.color red. So his hits are going to be red. Sorry, his hits are going to be blue, and any miss we see are going to be red. So if we run this, interesting things start to happen. But this is going a bit too slow for my taste. So let's speed this sucker up. And one of the ways we can do that is by drawing less actions, which is using some of this over here, which is that we can use the tracer function, saying, so what we'll do over here in our setup is we'll say bob.tracer. Another one of these functions that we're just going to learn today and only for today. 12 and 25. And then we run it, and it's going to just basically complete. Whoops. Turtle has no attribute tracer. Is it turtle.tracer? Yep, it is. And you see that just popped up like instantly, right? So let's go ahead and bump these numbers up. 10,000 trials, right? We're going to see what this looks like now. And something interesting starts to happen, right? That circle that we defined mathematically starts to appear, because because the circle defines essentially is defined by its radius. So everything within that radius is in the circle. And we get a bit of, weird jittering over here, but that's just because Bob is a turtle shaped, right? Isn't that cool? Let's see if we can't get it to go even faster. Let's see. And of course, we need to actually still show what's going on mathematically, that this is going to be calculating pi. Okay, tracer. Tracer is delay. Okay. Only the nth thing, only the nth regular screen update is performed. So we're going to do Geany. Whoops, and I accidentally closed everything, but that can be reopened pretty easily. Geany. We're going to do, sure, 120 and see what happens. Even quicker? Hope so. Yeah, that ran even quick. That's going even quicker now, because we're only showing every 100th frame every 25 frames, I think. So yeah. And then can we speed that up even more? I didn't speed anything up, I think. What about the other way around? 200? Sometimes you gotta play around with stuff and see what happens. All right, but this is again a Monte Carlo approximation, so let's go ahead and do some calculation. I think I'll just keep it capped at 1,000 right now because that should basically stop there. So what we do over here is we will copy. I'm gonna need to copy these things. No, I won't. I'll just return. Now, dist is less than or equal to 1, whether it was a hit or not. So I'll return that value, and that'll be, so I just added this line. And now what I'll do is I'll create a hits variable over here. Hits is equal to 0. Throw bob. If throw bob equals true, hits plus equals 1, and then what we're going to do is we will print out two things. Hits divided by trials, which is the percentage of hits we get, but that should approximate pi over 4, so we'll go ahead and multiply that by 4. So hits divided by trials times 4. And this isn't going to do a good approximation of pi, but it will approximate. Oh, assuming I name my variables right, hits as opposed to hits. So there we can see I got 80% hit rate for 3.2 as my approximation of pi. And of course, the more of these that I do, right, the more of these that I do, the closer I'll get. But, you know, graphically, this starts taking a toll on the computer in terms of computational time, right? So I'll run it without the graphics next one last time before I dismiss class. Because, as you can see, this is taking more than 10 times as long because the drawing is getting more and more complex. So let's go ahead and do that now. So without the graphics, we can just simply say, hey, here's Bob, here's all these things. We can just, and all we have to do to remove the animation is to remove this bit, which is the bits that say change color, go to here, go here. And Bob now is grateful and staying still, and we calculated that, hey, we threw him 10 times, he hit 3.1476 times, or sorry, 78% of the time. If we do 100,000, again, we keep closing in closer and closer on pi, 3.14, not 1, but I never said this was a great approximation, but it is a fun one. And that is sometimes part of the reason. 3.12, hey, we're starting to get there. So, let me go ahead and share this code with you, and then I will dismiss the class, okay? Copy this, then we will go to Runestone. Oh boy. And then over here, I'll put this, I will share this one. It says I must be logged in. Log out. Log in. Sorry. All right. Before I dismiss you, just remember, if you need any help, please let me know, and I will speak to you, and I can be available over the weekend. Save and run. And share code. It runs a lot slower in the web browser. That's one of the issues we have. But that's okay. Oh, wow. Why am I yawning so much? I was like a good boy last night. I went to sleep at my bedtime as opposed to staying up all night doom scrolling and looking for cat memes to cheer me up after aforementioned doom scrolling. Right? So, now one of my favorite pictures that I got over the past couple days was basically a picture of a. I'll see if I can't find it. Anyway, stop recording.